Hey, thank you for joining this session about physical science. We're going to be finishing up mechanics section 1.1. So we had so many formulas in this that we decided to split it up into two videos. So the first video had the formulas from the beginning of this section. And this is starting where we get 5 new formulas in the section called uniform acceleration. So in that page, it just kind of hits the student with 5 formulas, not a whole lot of explanation, not a lot is needed. They're all formulas for times when you know what the acceleration is and the acceleration is constant. But at this point, students are starting to feel overwhelmed. There are so many formulas. They had a bunch to begin with, and now they got 5 more. So I want to go over my explanation for how to choose a formula. I kind of have a 3-step process here, and here's the trick to doing it. You ask these questions. First question is, does the velocity change? If it does, then use formulas from a certain group. If it doesn't, use formulas from a certain group. Number 2, do you know the acceleration? Same thing. It's going to help you narrow down groups. And then once you've picked a group, you answer question 3. What are you actually solving for? What variable are you trying to find? So let's look at these formulas and how this works. So your first question, does the velocity change? So you may remember when we got the very first formula, it's for velocity, and it can be rearranged to solve for distance or time, but it's a formula that only works if the velocity does not change. So if it doesn't change, you're going to be using one of these versions of that formula, either solving for velocity or time or distance. So if your velocity does not change, if the question just talks about one single velocity, it doesn't say speeding up, it doesn't say slowing down, it doesn't say stopping, it doesn't say a starting velocity or an ending velocity, and it does not have the word acceleration, then lucky you, you get to use one of these formulas. However, a lot of them in this class are going to be a little more complicated. So if we talk about one where the velocity does change, then you can't use these. So that means you're stuck figuring out something from these two lists. So this is kind of still looks like a lot of formulas, but that's all right. We're going to narrow it down with question 2. So we've established, okay, the velocity changes, so we're doing something over here. Next question, does the problem tell me the acceleration? So you might notice that in all of these 3 formulas on the right, there's an A in there for acceleration on the right side of the formula. That means we have to know acceleration in order to solve for whatever value is on the left side of the formula. In this middle group, we never need to know acceleration. The right side of the formula never has acceleration. The only place it appears is over here, where we're trying to figure out what the acceleration is. So obviously we don't know it, that's what we're trying to find. So if you do not know the acceleration, okay, then you could use one of these formulas from this group, the unknown acceleration, one of those 4 formulas. If the problem does tell you acceleration, then you won't be using one of those, you'll be using one from this group on the right. Now, using those first 2 questions, we've narrowed it down. Instead of having to deal with like 12 formulas, we're trying to just choose between 3 or 4, so that's good. And then how do we make that final choice? We ask ourselves the question 3, what does the question actually ask you to solve for? So if we are in this third column over here with when we're given the acceleration, it's pretty easy then to figure out which formula we're going to use. Is it asking you for distance? If it is, use the one that starts with distance equals. Remember, distance is abbreviated with an S. If it asks for time, use the one that starts with time equals. If it asks for velocity, use velocity equals. So using those 3 steps, you should be able to narrow it down to one single formula, and then you'll be able to use that formula to solve your problem. Okay, so you might want to just kind of take a screenshot of this to help you figure it out. We're working on getting a handout on the student portal that has this set up so that you we've got that there as a resource. We don't have that up yet, but we should soon. Hopefully by the time this video is out, you'll have it. So if you're watching this later, just check the student portal and see if you have this screenshot under, or I'm sorry, if you have this formula page under section 1.1. And for now, we're going to do some practice questions where we use this method to figure out what formula to use and then actually solve the problem. So here's this practice question. A truck decelerates at a rate of 2 meters per second squared. So first of all, that's a weird word, decelerate. That just means slowing down, but it is an acceleration. So it says it decelerates at 2 meters per second squared. So that means if we have a formula that asks for acceleration, we could put 2 in there because a deceleration is just a negative acceleration. So our deceleration is 2 meters per second squared. If it starts with a velocity of 15 meters per second, how long will it take to stop? So let's go through our questions. Does the velocity change? Well, yes, it's telling us it's accelerating. It tells us it has a starting velocity, and we don't know the ending velocity, so it definitely changes. Okay, so we can't use that first formula. Second question, do we know the acceleration? Yes, it tells us that it's 2 meters per second squared. Okay, so that helps us narrow down which column we're using. So we're going to use one of these formulas that actually has acceleration somewhere on the right because we know what the acceleration is, so we can plug it in there. And so that takes us to our third question. We need to pick which formula to use. So our third question is how long, or I'm sorry, what are we trying to find? And what we're trying to find is how long will it take to stop? Okay, that's a time. How much time will it take to stop? So from this column, we've narrowed it down. It's got to be one of these 3 formulas. There's only one that starts with t equals to help us find time. So that's the formula that we're going to use. T equals v2 minus v1 over acceleration. So now we have to actually solve our problem. So we put in our numbers. So I'm seeing a problem here. We've got velocity 2, the ending velocity, minus velocity 1, the starting velocity. What it tells us it starts with a velocity of 15 meters per second, but I don't see another number there. How do we know about the ending velocity? All right, well, it says, okay, that's what it said. It starts at 15 meters per second, but the question also says it stops. Okay, how long will it take to stop? So our ending velocity is actually 0. So it might be a little tricky sometimes. You'll see questions like that where you're looking for a number and there's no number, but it might start from rest or it might slow down to a stop. And in that case, that velocity is 0. So we have our 2 velocities. We have 15 and we have 0. So our ending velocity is 0, our starting velocity is 15, and then our third number is acceleration, negative 2 meters per second squared. It's negative because it's slowing down. And so we've got that in there. So when we go to solve this problem, remember that anything on one side of a dividing line, you just kind of pretend it's in parentheses. You do that first. So you take 0 minus 15 first, and then you divide it by 2. So 0 minus 15 is negative 15 divided by negative 2 gives us 7.5 seconds. And that's our final answer. Next practice question. An object starting with a velocity of 15 meters per second accelerates at a rate of 3 meters per second squared. How far does the object travel within 10 seconds? So first we need to figure out what formula we're using. So first question, does the velocity change? Yes. Okay, it tells us that it accelerates at 3 meters per second squared. That's a change in velocity. So we can't use that very first formula. Now we've got, if you look back at your formula chart that I showed you, you've got to pick between the second and third column. So our next question is, do we know the acceleration? In this one, yes, we do. It tells us the acceleration is 3 meters per second squared. Okay, so that gives us this column, all the ones that have an A in them somewhere on the right. So we need to know acceleration to solve them. So we just have to pick from one of those 3 formulas. We do that by asking what is it asking us to find? Well, it wants us to figure out how far does the object travel. So we're looking for distance. So we start with the formula that asks us for distance equals, and that's this one. Okay, so we wouldn't want to start with one that says time equals, because we're not looking for time, we already know time. We're not looking for velocity, so we don't start with that one. We start with distance equals, and distance again is always an S. So I put that formula over here, distance equals. Now it kind of looks like a messy formula, so let's look at what we have. We have distance equals starting velocity times time plus 1/2 acceleration times time squared. Okay, so let's start putting our numbers in for that. Our starting velocity was 15, our time is 10 seconds. So we have 15 times 10. Our plus sign is still right here where it was. The 1/2 stays right there. We're going to use that. We don't change it. And we have acceleration and time squared. So acceleration is 3, because that's what it told us up here. And our time is 10 seconds. Now, an important thing to remember is that in this unit here, the t is squared and the acceleration isn't. So we're going to square our number for time. We have 10 seconds squared here, but we don't square this a. Okay, that is acceleration. The number is 3. And it throws people off sometimes because the unit for acceleration is 3 meters per second squared. And you might think like, well, okay, there's a square there. I'm supposed to do something with it. And I'm sorry, I know it's confusing, but because it's a unit, it's just a label that goes with that number 3. We don't actually do anything with it. So you don't have to do any dividing or do any exponents with that. You can just pretend it's a 3 that doesn't have anything else going on. Okay, so with order of operations, we do parentheses first, and then we do exponents, and then we do multiplication and division, and then finally addition and subtraction. So we do have some exponents here. We have 10 seconds squared. So our very first step, that's the only thing we change. So we have 15 meters per second times 10 seconds plus 1/2 times 3 times 100. So this is the only thing we changed is we did the exponent. 10 squared gives us 100. Okay, then we do multiplication before we do any addition and subtraction. So on the lefter part of it, we have 15 times 10 gives us 150. And then we have 1/2 times 3 times 100, which also gives us 150. So then our final step is to add those together, 150 plus 150, because this plus sign still stayed right here. We didn't do anything with it. So now we add them together, 150 plus 150, our final answer is 300. And one more similar practice question. A van is traveling at 11.5 meters per second. To avoid hitting a deer, the brakes are applied. The van stops within 3.5 seconds. What is the acceleration? So we go through our questions. Does the velocity change? Yes, it slows to a stop. We're looking for acceleration. Do we know what the acceleration is? No, that's what we're trying to figure out. Okay, so we're using one from that second column, one of these formulas. So to figure out which one, we ask ourselves our third question, what are we trying to find? We're trying to find acceleration, so we use the formula that starts with A equals. So if A equals V2 minus V1 divided by T, so that's A equals ending velocity minus starting velocity divided by T. So what are our numbers? Our starting velocity is 11.5. And again, we don't see a number for ending velocity, but it tells us the van stops. So our ending velocity is going to be 0. So because it stops V2 will be 0. So here are our numbers. Our ending velocity is 0. Our starting is 11.5. Our time was 3.5 seconds. Remember that we do this first, the stuff on one side of that dividing line. So everything on top gets done first, everything on bottom gets done, and then we divide the top by the bottom. So we take 0 minus 11.5, which gives us negative 11.5. We divide it by 3.5 seconds and get our final answer of negative 3.29 meters per second. So why do we get a negative number? It makes sense because it's slowing down. So acceleration, if it's speeding up, is positive. Acceleration, if it's slowing down or decelerating, is negative. Now at the end of this section, we talk about things that are falling. So objects that are in free fall are things where the only force acting on them is gravity. So in the real world, there's always air resistance, but we're going to pretend there's not, and we're just going to talk about free-falling things where the only force on them is gravity. So because that's the only force on them, they have a constant acceleration due to the gravity pulling on them. That acceleration is always going to be the same on Earth. It's always going to be 9.8 meters per second squared. So it doesn't matter if the object is heavy or light, the acceleration due to Earth's gravitational pull is always going to be the same rate, 9.8 meters per second squared. So to solve problems about falling bodies, we can use the formulas that we just got for things with uniform acceleration, where we know the acceleration. And what we do is just have different versions of that formula where we've replaced the letter A for acceleration with G, because G is the acceleration due to gravity, and G will always be 9.8 meters per second squared. Okay, so again, objects that are falling are accelerating at that rate. We abbreviate it with a G. It's the same formulas as before. We've just replaced A with G. So our formula, if we want to solve for the ending velocity. So we say something has been falling for this many seconds. How fast is it going? That's the formula that we use. So it's the same formula that we had before, except we replaced A with G, because we'll know that G is always 9.8. Formula if you're solving for distance traveled in a certain amount of time. So again, an object falls for a certain number of seconds and you want to know how many meters did it fall. This is the formula to use. And our third one is the amount of time of the fall. So based on how fast it's going, an object's falling and it ends up moving at a certain speed, how many seconds did it take to get to that speed? So because we know the acceleration with falling things, these are the only three formulas you would use. So we looked at 10 or 11 formulas before when you're talking about stuff moving on flat ground. But if something is falling, it's a little easier. We've only got these three formulas to pick from. So some example questions here. If a coin is thrown with a starting velocity of 0 meters per second down a dry well and hits the bottom in 1.2 seconds, what is the depth of the well? So first of all, it was nice enough to tell us in this problem that the starting velocity is 0. That will not always be spelled out for you, but that's usually the case. If something is being dropped, it started out not moving, so it started out with 0 and then it was dropped. It's let go and now it's moving. All right, so let's figure out what we're doing here. So we've only got three formulas to pick from. It asks what is the depth of the well. So that's the distance. So we want our distance equals formula. So distance equals starting velocity times time plus 1/2 times g times t squared. So we just fill in our numbers. Our starting velocity was 0. Our time is 1.2. The plus and the 1/2 just stay there. G is always going to be 9.8 and our time is 1.2. And remember, we're going to square this number, 1.2. We're not going to square the G for 9.8. That just stays how it is. Okay, so we do our exponents first. So 1.2 squared gives us 1.44, so that's the only thing changed in that step. Then we multiply our stuff first, so 0 times 1.2 gives us 0, plus 1/2 times 9.8 times 1.44 gives us 7.056. So 0 plus 7.056 gives us our final answer of 7.056. Okay, and that's the last practice question we have here. If you do have any more questions for your instructor, don't hesitate to contact us. You can email us or you can call and speak with us on the phone.